exponents that are also referred to as powers represent repeated multiplication, and they are usually written in terms of base and an exponent. Exponent is the number that indicates number of base factors. So let's do some examples. So here we have examples of repeated multiplication, and we will just practice how to rewrite those in terms of exponent form. First example, we have 7. It's the number that is being multiplied by itself, and we have 3 factors of 7. So 7 to the power of 3 is 7 times 7 times 7. In the second example, we have 4 factors of 11. So 11 is the base and the power is 4. In example number 3, negative 2 is the base, and we have 5 factors of negative 2. However, exponent only works on whatever is immediately to the left of it. Now, immediately to the left of it, there is only 2. It will not have power over this negative unless we put negative 2 inside of the parentheses. In third example, we have x, and it's being repeated 3 times. In example number 4, we have y, and we have 2 factors of y. Fifth example has mixed letters, and we have 2 different bases. There is x and there is y. X is being repeated 2 times, y shows up 3 times. In this example, we have 2 to the power of 4 plus 3 to the power of 3, and we have to evaluate it. 2 to the power of 4 means we have 1, 2, 3, 4 factors of 2 plus 1, 2, 3 factors of 3. So now we get 2 times 2 is 4, times 2, 8, times 2, 16, plus 3 times 3, 9, times 3, 27. Same signs, we calculate sum, so 27 plus 16, 6 plus 7, 13, carry the 1, 1 plus 2, 3, plus 1, 4. And the sum of 16 and 27 is 43. That's our answer. These examples represent what happens with negative signs and exponents. So in the first example, we have 3 factors of negative 2. Remember that exponent only works on whatever is immediately to the left of it. So we have negative 2, negative 2, negative 2. We have 3 factors of negative 2. Now to simplify this, negative times negative, we have positive. Positive times negative, the sign will be negative. 2 times 2, 4, times 2, negative 8. In the second example, we have negative 2 to the power of 4, and the exponent is applied to entire parentheses. So we have 4 factors of negative 2. Negative times negative, positive, times negative, negative, times negative. The answer is positive. 2 times 2, 4, times 2, 8, times 2, 16. If you have an even power, all of the negatives will have a pair to become positives, and the final answer will be positive. If you have an odd power, you will have an odd number of factors that will always be multiplied by that extra negative sign to turn the final answer into negative. So negative number raised to even power will produce a positive answer, and negative number raised to odd power will produce a negative answer. Example number 3 has negative 2 to the power of 4. 4 only works on whatever is immediately to the left of it. So without a parenthesis, it has no reach for that negative sign. It will not be repeated. And now we have 4 factors of 2. So we have negative times positive times positive times positive times positive. The whole answer will be negative. 2 times 2, 4 times 2, 8 times 2, 16. Example number 4 is another tricky version of this. This 4 applies to the parentheses. It has no reach towards the negative sign. So negative is outside. And we have 4 factors of 2. And this ends up being negative 2 times 2, 4 times 2, 8 times 2, 16. Evaluate negative a half to the power of 4. Now all this means is that we have 4 factors of these parentheses that have negative a half inside of them. And now it's just multiplying fractions. Here we have negative times negative, positive times negative, negative times negative again, positive. Good, because we were raising a negative to a positive power, so that checks out. 1 times 1 times 1 times 1, we have 1 in numerator. 2 times 2, 4 times 2, 8 times 2, 16. So 1 out of 16 is our answer for example number 1. In the second example, we have 3 factors of negative 2 out of 5. And we simplify signs. So negative times negative, positive times negative, negative. 2 times 2, 4 times 2, 8. Out of 5 times 5, 25. Times 5, 5 quarters give us 125, and negative 8 out of 125 is our answer. Evaluate 0.2 to the 4th power. So we have 4 factors of 0.2. So now we have to multiply decimals, and they can be multiplied as whole numbers if we remember how many decimal places we have. Well, we have 1 decimal place here, 2, 3, 4 decimal places total. So now we can calculate 2 times 2 times 2 times 2 by hand. 2 times 2, 4 times 2, 8 times 2, 16. Now we have 4 decimal places to give back. So 1, 2, 3, 4. Fill in empty spots with zeros. 0.0016 is our answer. Evaluate 3 to the 2nd times 2 to the 5th. 3 to the 2nd means we have 3 times 3. We have 2 factors of 3. 2 to the 5, we have 5 factors of 2. And now it's just a multiplication problem. 3 times 3 is 9 times 2 times 2 times 2 times 2 times 2. 9 times 2, 18 times 2 times 2 times 2 times 2. 18 times 2, 36 times 2 times 2 times 2. 36 times 2 is 72 times 2 times 2. 72 times 2 is 144 times 2. And 144 times 2 is 288. And that's our answer. That's all.